Alright guys, so this video is on the Introduction to Quadratics, page 28. The essential question is, what are the key features of a quadratic graph? You're definitely going to want to pause this video throughout and take some notes. Everything you see me write or have written, you should absolutely have down in your notes. All of this information is going to make the rest of this Desmos activity very straightforward, so you want to have this information right in front of you, and it could be on your next notebook check. Okay, so first, what is a quadratic equation? So here is the general form of the quadratic equation, and we call this form standard form, sort of like we call y equals mx plus b slope-intercept form. And there's other forms we can have of linear functions. This is the standard form of quadratics. So what is a key feature of a quadratic equation? You know you're looking at a quadratic equation when your highest power is 2. And if you remember from Monday, that means that the degree is 2. So you'll notice this highest exponent right here is 2. Pause right now and get that copied down. All right, so now we're going to look at what graphs look like. What are graphs of quadratics? So what do they look like? So the shape of a quadratic graph is called a parabola. And that refers to the curve that the parabola makes. And so sometimes you'll see quadratics that get really steep, sort of right here. And it'll appear to become perfectly vertical, but it never actually is. It's going to continue to grow out in those directions. All parabolas do reach a certain point and turn. They only have one turning point. And you'll notice that this one is facing up and this one is facing down. So that's important to notice as well. I do want to go back really quick to standard form and point out that A, B, and C are just placeholders for numbers. So A and B are coefficients and C is just a constant. All right, so getting into some words that we use to describe or analyze a quadratic graph. So, vertex. Vertex is the turning point. And so you can see here that this turning point is 2, 1. And as you saw on this last slide, you can have turning points that are at the bottom or at the top of the graph. So when we talk about turning points, we also use one of two words to describe them: a maximum or a minimum. And so we have to know which one we're looking at. In this case, this is the lowest point, so this turning point is a minimum. So every vertex is either a max or a min. You have to be able to decide which one it is. All right, and then the axis is symmetry. So when you're looking at this graph here, does it look symmetrical? Yeah, if we imagine folding the paper right there, this part of the graph and this part of the graph would fold directly on top of each other, so it's symmetrical. So we imagine our axis of symmetry right here, and it will always go through your vertex because that vertex is that turning point. So it's always going to go through the vertex. And this is something you don't always see on graphs. So it's an imaginary line that cuts the parabola in half. And it's always written x equals some value because this is a vertical line, and that always has the equation x equals some number. And you'll notice it will always be the x value from the vertex. And notice this goes through the x-axis at 2. So this axis of symmetry is x equals 2. Axis of symmetries always have x equals. It will always match the x value of the vertex. All right, your y-intercept. So a couple of things. Vertex, axis of symmetry, and y-intercept are things every single quadratic will always have. So that's important to know. So you might want to write that quadratics will always have a y-intercept. So in this graph, we're familiar with y-intercepts. It looks like it's at 0, 5. And that is the point where the parabola crosses the y-axis. And that point is 0, 5. Definitely want to have the graph drawn for yourself so that way you can make note of all of these features that we have drawn on them. All right, so top 3 things: vertex, axis of symmetry, and y-intercept are 3 things a quadratic will always have. Now we're going to talk about something that quadratics may or may not have, and that is x-intercepts, also called solutions. So if I ask you what the solution to the quadratic is and I give you a graph, you're looking for the x-intercept. So these 4 terms refer to the same information on the graph. So if you're given a graph or able to graph something and you need to find the root, the zeros, solutions, or x-intercepts, you're all going, every single time, all 4 of those words, you're going to look in the same place on the graph. So we've got some pictures here. There's 3 scenarios that a quadratic graph can have. You can have a scenario where your quadratic graph crosses the x-axis twice. And so here you would say there are 2 solutions, or 2 roots, or 2 roots, or 2 zeros, or 2 x-intercepts, or 2 solutions. So these words, for the most part, are interchangeable. We'll talk about more what each word means in Algebra 2. Okay, you can also have this situation, where your quadratic comes down to the x-axis or comes up to the x-axis and turns away. And so in this case, we only have 1 x-intercept. All right. It has 1 solution, 1 x-intercept, 1 zero, 1 root. And then here, you have no real solutions. You might ask why the other 2 don't reference real. Well, you can say 2 real and 1 real. In fact, that language is going to be important in Algebra 2 because in Algebra 2, we learn how a quadratic like this could have 2 imaginary solutions. But we don't have to worry about that just yet. So we say that there are no real solutions. So it will never cross the x-axis. And there you have it. 4 very important ideas to get you started on quadratics and a basic definition of what they look like in an equation and on a graph.